All right, so this will be 101 to 107. I ran out of time in that previous lesson set video. And boy, I tried to get a lot of problems done quickly, and I realized that probably wasn't the best way to do things. But I didn't have time to finish, and the room was going to get used, and I got to write everything down again. So my apologies, but best I could do. All right, so I'm going to do problems 101 to 107. And again, we're doing this so much volume and we're doing problems quickly so that every day we do this. It's like times tables. We overlearn what we're looking at so that you can bring it into the next level, because everything that you're going to be working with is based on foundation. Foundation's everything. And if you don't have a strong foundation, you have to drop out, and most people do. All right, so we want to try to correct that with our practice sessions. And so let's talk a little concept here. I got time now to do this a little more justice to the cause. Renee is ready to roll. Look at that. Renee, the card is ready to roll. Let's have at it. Now, some students have trouble with the concavity of a square root function. Square root function takes the area, 1, and it asks for what's the side length. Area of a square 4, its side length is 2. Area 9, it's 3. So what can we see if we look at table values? Well, we can see that it takes more and more area to just go up 1 notch in side length. So if you plot these numbers, 0, 0, 1, 1, 4, 2, 9, 3, we can see the concavity. Well, this is going down, so that's your concavity. -3, 5, right? Because we can't take the square roots of negatives on the Rene Descartes coordinate system. This is Rene Descartes. Got mixed up there. I'm a big fan of the square root of 25. I think it moves us to the right far enough that we can get a good sense of approximations. So I'm going to pick 22. And if I get that, I'm going to get what? -10 plus 5, -5. Now let's just check our slope. Not our slope, but our A term. A, x minus h plus k format. Okay. 5 to -5 is down 10. When I drop 22 in, I get the square root of 25 for change. Yep, that sure looks like the number -2 to me. Rise over the square root of run. And let's get one more value here. Let's go to not 100, but let's go to 49. So that might be where 49 is. All right, if I put 49, I need 49. So I'm picking 46. Well, that's going to get me 7 units of change. -14 plus 5, -14 plus 5. My brain's slow right now. 9. -14, -9. Okay, and hopefully that starts to look somewhat appropriate in terms of concavity. All right, enough said there. I prefer to find the vertex, which in this case is 1/2. Gets me a 0. Y equals the absolute value of x. So that's y equals x. What happens when I slap an absolute value of it? The negatives become positive and it gives us a V shape. All I'm doing is going up 4 times as fast, shifting the vertex. I'm not going up 4 times, I'm going up 8 times as fast on the right and down 8 to 1 on the left. Let's prove that. Well, let's get -9 goes with that. Okay, so let's put a 0 in and prove that I'm going down at 8 to 1 on this side, which means I'm going up 8 to 1 on that side. And you should be thinking about those piecewise problems we did in the other video. All right, so if I put a 0 in, the absolute value of -1 is 1. 4 minus 9 is -5. How far is it from -5 to -9? I've gone down 4. How much have I changed my x's by? A half. Well, there you go. There's your 8 to 1. 4 times 2. Hopefully it proves that. All right, so what are the salient characteristics of this graph? Well, I can see the end behavior is 5/2. And you got to crunch some numbers. Put 1,000 in here. 5,000 plus 10 over 2,000 minus 6. I hope you can see what dominates. What dominates end behavior are the biggest terms. These numbers are going to get infinitesimally small as I keep adding zeros to the problem. I could have put 10,000 in, and I'm closer to 5 over 2. I can look at the numerator and find my x-intercept. Looks like it's -2. That gets me a 0. I can plug a 0 in to find the y-intercept. 10 over -6, -5/3. Maybe that's about there. So 0 gets me -5 over 3. And I can see it's undefined at x equals 3. That's 2 units. 2, I'm going 3, right about here. Oh, I can see this now because it's going to go to 5/2 here. Why do I know that? Because I could have put -1,010,000 or whatever I did up there. All right, so I can see this now. Does this. And there are no more x-intercepts. There's only one. And if you want to make sure that's right, you got to work with numbers. Pick a number bigger than 3. How about 4? I should get a positive value above 2.5. 20 plus 10, 30. 2 times, what did I pick? 4. 2 times 4 is 8 minus 6 is 2. Does it look like I'm going up quicker than that? I should have. Boom. There we go. A 4 got me what? 15, I think I got there a minute ago. And you got to play with numbers to see what the trajectories are. All right, I've had students who can graph this at the end of the term in under 10 seconds. All right, so base 3. Let's get 3 points on this. But right now I can see division by 1, division by 1. So if x equals 5, that's where the asymptote of the log is. Then 6 should be a friendly number because that's 1 unit of change, and 3 units of change, 8, because logs have differentials just like exponential functions do. So if I put a 6 in, I'm going to get 2020. We'll do it in a second. If I put 8 in, I'm going to get 2024. Let's prove it. 6 minus 5 is 1. I don't care what the base is. What do you put on top of b to get a 1? 0 takes care of the multiplication. It's gone. 2020. Let's put an 8 in. 8 minus 5 is 3. And if the base is 3, I think I'm getting 1, 4. 1 times 4 is 4 plus 2020, 2024. That's the mechanics. If I want to get this value down here, well, I already have a 3-to-1 ratio. So I'm assuming 1/3. 1/3 differential. So that's going to be what? X equals 3. I erased it. So 3 1/3 should get me 4 less than 2020, 2016 without looking. I hope I'm right. I'm adding, what did I add? 1/3 to 5. I had the wrong number here. Well, x equals 5. Okay, I erased it. So 5 1/3. 5 1/3 should be very friendly. What's 5 1/3 minus 5? 1/3. What exponent puts on top of 3 to get 1/3? -1. 4 times negative. Oh, yes, I'm going down 4 from 2020. We got patterns here. Keep your eyes open for them. All right, we got an exponential that looks like this, up 24. So I guess I go up a little further. 1/3 of that is up 8. So I already know my y values. Right, that y value is 20, 30, 38. This y value is 22. If I pick the right numbers, what numbers do I want to pick? 7 and 18. And you work with them and you'll see that 7 gets you 38 and 18 gets you 22. Let's do 18 gets us 22. 18 minus 7. Oh, 11s. The 11s cancel and give me 1. What's 1/3 of 24? 8 on top of 14. There's your 22. There's your graph. 5 cosine x plus 7. Well, the cosine curve is width, and that width is 1. And that takes place at 0. So I now know that 0 gets me 12. That's a max. 0 gets me 12. And then I come around again. Oh, I'm back at the same place, 2 pi. 1 revolution, go Che. I'm supposed to do the left hand. There we go. So what X do I pick? I pick 2 pi. And I get back to 12. Then we got all kinds of symmetry, right? Pi's got to get me what here? What's the midline? The midline is 7. We're up to 12. We're going down 5 to 2, which means that pi over 2, where we don't have any width, the width at pi over 2 right there is 0, plus 7 gets me 7, right? So lots of symmetry here. Lots of symmetry. So you get 1, you get them all. All right. Last is just playful time, 107. On every lesson set, it's going to be a friendly, playful moment. So if you watched Algebra Trig in 90 seconds, and what is a radian? What is a radian? All right, those 2 videos are very helpful here. So I start at 0, and I go up. Pi over 2 is about 1.57. 2 pi is 3.14. I'm doing radius lengths. It takes 3 and a little more than 3 of these. There's 1, there's 2, there's 3. 3.14 is a little further. 6.28 all the way around. And I got to go from 6.28 to 7, which is 0.72 radians more. If that's 0 and 1.57, that's a little less than halfway. Oh, I know halfway is 45 degrees. Right? And I know 45 degrees gets me root 2 over 2. And I've asked you since the first day of the term to memorize these decimals. That's 0.71. Well, if I'm a little less than halfway, then my dot is a little further to the right. And so I'm adding a little bit of difference, a little bit of length to 0.71. So we're somewhere in the middle 70s. 0.76 is a guess, 0.75, somewhere in there. Be a quick guess. So go to Google, do the cosine of 7, find out. I'm gonna Google it right as soon as I end this video. All right, so there, a little more time spent on those graphs, not quite so hectic because I had to finish up and I tried to finish up and I got the second phone call and I couldn't pass that one up. I would have been in trouble. There, get that hair, mat it down. There we go. I can end now. All right, stay safe, stay warm.